first thing we need to do is graph it. So to be able to graph a line, you have to identify its slope and y-intercept. What is the slope here? 2 over 3. That means we're going to go what 2 and right 3. What is its y-intercept? So when graphing it, what do we take care of first? You plot the y-intercept and it's a positive 2, and since it's a y-intercept, you plot it on the y-axis. Okay, so then you go up to right 1, 2, 3, and then up to right 1, 2, 3. And you go down to left 3, down to left 3. Is this going to be a dashed or solid line? Dashed. Okay, before we shade, this point is 0, 2, right? Because you don't go left or right, so the x value is 0, but you do have to go up 2. So if I'm using that point as my test point, when I rewrite this, y is greater than 2/3 times x plus 2. What will I fill in for the y place if this is my test point? 2. Remember, that's the y value. And what will I plug in for this one? 0. What's 2/3 times 0? What's 0 plus 2? So don't you end up with a statement that says 2 is greater than 2? And that's not true, is it? 2 is not greater than 2, it's equal. So for that to have worked, it would have had to have had an equal to bar. That's not true. Okay, let's try another one. What are the coordinates of this point? 34. Okay, not 34. So 3, 4. 3 is the x value of the point, 4 is the y value. So down here, I'm just going to quickly replace the x and the y with our new test point. What goes in the y place? 4. And what goes in the x place? 3. Type in 2/3 times 3 plus 2 and see what you get. 2/3 times 3 plus 2. Okay, you get 4. You can't type in 2/3. I know. Okay, I'm going to show y'all something really quick. I know you, guys, I'm trying to teach. Is 4 greater than 4? No. So see how that one didn't work either? So that leads me to believe that no point on this line, since it's dashed, will be a solution. Let me show y'all something really quickly, though. For those of you who immediately pick up your calculator to do this, let me show you how easy it is to do without your calculator. Aren't all whole numbers over 1? What's 2 times 3? What's 3 times 1? What's 6 over 3? 2 plus 2, 4. I know you have a calculator, but I want y'all to all understand that without a calculator, you can do that. Okay, all you do is throw the whole number over 1, multiply straight across, simplify, and add the 2. Okay, so now, even though there are no solutions on the dashed line, there are solutions, and they're located where? What's that symbol? Greater than. So if I go to my y-intercept, which is sitting at 2, which numbers are greater than 2? 3, 4, and 5, or 1, 0, negative 1? The ones above it. So that lets me know I'm going to shade above the line, and that's where all the solutions are. So now let's pick a test point in the shaded area. Anybody want to pick a point? 5, 1 is not in the shaded area. 1, 5, 1, 2, 0, 0 is not in the shaded area. Okay, well let's see. 0, 0. If I plug in a 0 here and a 0 here, it'll make this side 0, but what will it make this side? Is 0 greater than 2? That's a false statement, and it should be because that point's not in our shaded area. If we pick a point in the shaded area, how about instead of 5, 1, negative 5, 1? Isn't that in the shaded area? So negative 5, 1. So negative 5 is your x value, 1 is your y value. So now if I go down here and erase what I was plugging in earlier, what do I now plug in the y place? What do I plug in the x place? Now, without a calculator, that's going to become 1 is greater than. Can't we just throw that over 1? But this one's not going to work out as nice. It's going to be a decimal. Because look, 2 times negative 5 is negative 10. 3 times 1 is 3. But negative 10 over 3 is not a whole number. So type it in. Everybody type it in. Well, you got to remember to add the 2. What? Did you add the 2? It should be negative 1 point something. Because you're adding 2 to the negative 3. Okay. So is 1 greater than negative 1.33? Yes. And that it worked because the point was in our solution area, our shaded area. Okay, number 6. Okay, so let's look at number 6. For number 6, what is the slope of this line? Negative 1 over 1. Does everybody understand where we got that? Because look, isn't that an understood negative 1 by the x, and you can make it a fraction by putting it over a positive 1? What is the y-intercept? Negative 1. So to start graphing this, we plot our y-intercept at negative 1. Then from there, what direction does the slope tell us to go? Down. And then I can do that many times. Or if I wanted some points over here, I could go up 1, left 1. And it makes sense that our line is going down from left to right because we have a negative slope. Should we have a dashed or a solid line? Solid. Look, there's an equal to bar, which means you do a solid line. What does that mean about the solutions? Right. All the points on the line are solutions, and all the points where? Above the line. Greater than, which would be this way. So you shade above the line. Raise your hand if you're having trouble understanding where to shade. Okay. This is the best way I know how to do it. What? Yeah, Isabella's going to say her way, and then I'll say mine. Yeah, it's going to kind of be dark on it.
If it points left, you shade top
What?
She's saying if it points, see how both of these are pointing to the right, so you shade to the top of both of them? Okay, this is the way I think about it. I notice that it's a greater than sign. Okay, so greater than. When I go to my y-intercept, it's negative 1. So which numbers are greater than negative 1? These numbers, like 1, 2, 3, 4, and 5? Or these numbers, like negative 2, negative 3, negative 4, negative 5? These numbers are greater than that one, right? So I shade on that side where the greater numbers are. Yes? Are you talking about when you divide by negative? Okay, number 7. What's the slope? 0. And then, you don't have to, but it helps some people to go ahead and throw it over 1 so they know they're going up 0, but they are going right 1. What's the y-intercept? 0 as well. So when you start this, what are you going to do? Plot a point at the origin, and then if you move up 0, right 1, aren't you just making a horizontal line? And doesn't it make sense that it's horizontal? Because does a horizontal line have any kind of steepness at all? No, which makes sense because it's 0 slope. The bigger your slope gets, like the higher number slope you have, the steeper the line. So 0 slope would be no steepness at all. Now, as far as shading, okay, it says greater than 0. So if I go to where I started my line at 0, which numbers are greater? These or these? These are greater than 0, right? So you shade on that side where the bigger numbers are. How do you do it when it's like that? Yeah, you still shade. Because think about it. Any number you picked up here, like pick a number in that area. A point. Negative 32. Isn't every single point up here going to have a positive y value? And think about it. If you plug in a positive y value, aren't they always going to be greater than 0? So that's why these are solutions, because these are all the points that are going to have a y value greater than 0. Down here, the y values would be negative, so they wouldn't work. Okay, number 8. What's the slope? 1 over 1, because there's an understood 1 here, and we need to make it a rise over run, so we throw it over 1. That means we're going to go up 1, right 1. What's the y-intercept? Okay, so to graph this, what do we do first? Plot 3, and then from there, up 1, over 1, up 1, over 1, up 1, over 1. Right? Or you can go the exact opposite, down, left, down, left. Now, once we're done, is this going to be dashed or solid? Dashed. So, and there's so many points, you barely have to do anything to make it look dashed. Okay? So, we don't find the solutions on the line because it's dashed, but we can find the solutions where, Juan? Above. Okay, so think about it like this. If we go right here to the y-intercept, it's at 3. Which numbers are greater than 3? 4, 5, and 6, or 1 and 2? Right, so we shade on that side where the numbers are greater than our y-intercept. Are people now understanding how to shade? Okay, I want you to take a second and try 9 and 10 by yourself. Number 9, what's the slope? Okay, so you chose to put the negative on the 4. That's fine. Some of you may have chosen to put the negative on the top. It doesn't matter. What is the y-intercept? Negative 2. So we plot our y-intercept to negative 2. And then it's a good thing she chose to put the 7, there, the negative on the bottom. Because if you'd have chosen to put it on the top, can you go down 7? No. So we need to go up 7 and left 4, right? So right there. It's a negative 4, which is left 4. And think about it. Which would have been down 7, right 4. But can you go down 7, right 4?
I went up 7, right 4.
Yeah. And think about it. Okay, so think about it like this, Samantha. Had you gone up 7, right 4, wouldn't you have ended up with a line that looks like this?
Yeah.
And should you have a line going up with a slope that's negative? No. So your line, is it dashed or solid? Dashed. Because there's no equal to bar. Okay, and then all the solutions are where? Less than the line. So if you go down to our y-intercept, which numbers are less than negative 2? Negative 3, negative 4, negative 5? Or the numbers above it? Right, those are numbers less, so you shade below the line. No. All right, number 10. What's the slope? You can't flip it. You can move the negative to wherever you want, but you can't flip the fraction. Somebody said negative 4 over 3. What is the y-intercept? Negative 2. So what do I do first, William? Where? Okay, and from there, what do I do? Or if I want to point over here, what could I do, Juan? Okay. Up 3, left 4. Should it be dashed or solid? See how there's no equal to bar? That means dashed. When there's an equal to bar, like this one, you do a solid line. Shh. Guys, don't ask me a question and not pay attention. Okay, now I need to shade where? What is this sign? Greater. So when I look at this number, it's the y-intercept's a negative 2. Which numbers are greater than negative 2? These or those? These are greater than negative 2. So I shade above the line. You're just looking for the numbers that are greater than your y-intercept, basically. Okay, next page. All right, I want you to try these 4 by yourself. You have 4 minutes. We plot our y-intercept to negative 3. Okay, before I even graph this line, is this line going to go up from left to right or down from left to right? So maybe we should go ahead and write like this, just so we know at the end that our line should be going up because we have a positive number for our slope. 3/4 is positive. There's no negative sign out there. So our line at the end should be going up. Now, from our y-intercept of -3, we go up 3, right 4. Or, to get a point over here, we could have gone down 3, left 4. Do we do a dashed or a solid line? Solid, because there's an equal to bar under that less than sign. But since it is a less than sign, okay, this -3. What numbers are less than -3? Numbers like -4, -5, and -6, or numbers like -2, -1, and 0? Below it are less than -3. So you shade below it. Samantha. Don't give up. Okay, number 12. Oh, and didn't our line end up going up like we said? Okay, number 12. What's our slope? -1/1. Because isn't that an understood -1 right there beside that x? And you need to make it a fraction so that we have a rise overrun. So doesn't that mean we're going to go down 1, right 1? Well, since our slope is a -1, doesn't that mean at the end our line's going to be going down? Because our slope's negative? So we start by plotting our y-intercept of 1, and then we go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1, over and over. Or we could have gone up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Is this a dashed or a solid line? Solid, because there's an equal to bar. So all of the points on the line are solutions. Now, it says to shade every, okay, look, and our line going down like we predicted because it's negative. Always check that. It says less than. So if you go to your y-intercept of 1, what numbers are less than 1? Numbers like these or numbers like those? These. The negative numbers are less than 1, right? So we shade on that side, the numbers less than 1. Oops. I know. Oh well. Okay, number 13. What is the slope? So that means we're going to go, and what's the y-intercept? Is our slope a positive number or a negative number? So our line's going to be going up at the end, okay, because we have a positive slope. Okay, so now we start by plotting our y-intercept of 4, and then we do what the directions tell us to do. Up 2 over 1, or down to left 1, down to left 1, down to left 1, down to left 1, down to left 1. It's very important to make as many points as you can because in the next unit we're going to be moving into where we graph 2 lines and we have to see where they intersect. And the more points you have, the better. Okay, it's a solid line because there's an equal to bar. And it says greater than. So we shade numbers greater than 4, which are numbers like 5 and 6. Well, technically, does the x-axis stop at -6? So technically, I could shade forever this way and forever this way. Because the line, doesn't this line continue going like that? So I could shade a lot. Okay? Alright, number 14. What is the slope? Where do y'all want to put the negative, the 3 or the 2? Okay? So that means we're going to go... Okay, since our slope is a negative number, our line's going to end up going down at the end, right? What's our y-intercept? 4. So we go up 4, plot our point, and then from there we go down 1, 2, 3, right 2. Down 1, 2, 3, right 2. We can't go up 3, we run off the graph. Down 1, 2, 3, right 2. You go off the graph a little. Okay, now it's just a less than sign, so what does that mean about my line? Dashed. Okay, but then we need to shade everything less than that. So if you go to your y-intercept, which is 4, what numbers are less than 4? Okay, so you shade below it, all the numbers less than 4. I'll try my best. Oops. No. Because we're about to get to some that are harder, so.
Yeah, I don't like those.
Okay, turn to the next page. Okay, I'm not going to do that one because it is an easy one like the ones we've been doing. Let's look at number 16. Okay, right now, are we ready to identify the slope and the y-intercept? No. Why not? It's not in y equals mx plus b form. So it's a good thing we spent some time a couple of weeks ago learning how to solve literal equations. Because we need to solve for what variable here? Y. Because y equals mx plus b. We want y by itself and everything else on the other side. So to get this y by itself, what do we do first? Right? So now we have 2y is less than 6 minus x. But since I want it to be mx plus b, couldn't I go ahead and reverse that to negative x plus 6? Now what do I do? Divide by 2. Hold on. Y is less than, isn't that an understood 1 right here? So isn't that like negative 1 half x? And then what's your b simplified to? 3. So my slope is negative 1 over 2. So at the end of the problem, my line's going to be going down because my slope's negative. What's my y-intercept? 3. So I start by plotting my y-intercept at 3. And then from there, to get my next point, I go down 1, right 2. Down 1, right 2. Down 1, right 2. Or, okay, is it going to be dashed or solid? Dashed, because there's no equal to bar. It's just a regular less than sign. And then it says shade less than. So if you go to your y-intercept of 3, which numbers are less than 3? 2, 1. Right, these numbers. So you shade below the line. Okay. Oops, all right. Number 19 is the last one I'm doing. The rest will be for your homework. Okay. Pay attention. Is this in slope-intercept form? No. You definitely want to pay attention to this one. To get it in slope-intercept form, what do we do first? Subtract the 3x. 1, I just said you're going to want to pay attention to this one. Those cancel, and you're left with negative 4y is less than or equal to negative 4 minus 3x, or we could just go ahead and reverse that, Isabella. Okay, then I need to divide by negative 4 on both sides. Don't the negative 4, or doesn't the negative 4 over negative 4 cancel out because it's just 1y? No need to write the 1. And then what does negative 3 over negative 4 become? Positive 3 over 4. X, and then what does negative 4 over negative 4 become? Positive 1. Okay, anything divided by itself is 1. So what's the slope? So what's my line going to be doing at the end? Up. It's a positive slope, so it's going to be going up. What's my y-intercept? 1. So I start by plotting my intercept at 1, and then I go up 1, 2, 3 over 1, 2, 3, 4. Or down 1, 2, 3, left 1, 2, 3, 4, and then I can't do it again. Is it dashed or solid? Solid. Okay, stop there. Don't do the rest because you'll end up having to erase. Okay, it says y is less than or equal to the line. So less than the line would be where? Below it. So if I shade below it, let's pick a test point down there in the shaded area. What's the test point down here in the shaded area? How about like 2, 1. Okay, 2, 1 is in that shaded area. So if I use a 2, 1, that's the x value, that's the y value. Keep watching, keep watching. 3 times x minus 4 times y is less than or equal to negative 4. If I'm using the test point right here of 2, 1, What number do I plug in here? What number do I plug in here? What's 3 times 2? What's 4 times 1? What's 6 minus 4? Is 2 less than or equal to -4? Guys, you're not paying attention. You just told me 2 is less than or equal to -4. Sit down. Sit down. Why did that point in our shaded area not work? Because when you divide by a negative number in inequalities, you must flip the inequality sign. So we should have shaded this side. And then points up here would have worked. Does that make sense? Yeah. You need to do the rest of them for homework.